Awesome. Welcome, friends. Welcome again. My name is George, and today we'll be talking about a cool new library, new to this series, Pandas. And today I'm joined by my great friend, Kathleen. She'll be doing most of the presentation for us. And we have friends all around the world, so welcome everyone. If this is your first time, I want to make sure you feel welcome. Share a little bit about yourself on the chat, and make sure to join our Slack, which I'll be posting on soon. Myself, Robert, and David, as well as Dimitri, we also cover different topics from time to time. We've covered machine learning so far. We've covered some data visualization topics, and today we'll be covering the very popular library Pandas in Python. Let me post some links on our chat. So if you're new here, you can join us on Slack. This session is recorded like every other session, and we have a YouTube playlist that I'm sharing here as well. Cool. And just to kick off the conversation on the chat, let us know if you've used Pandas before or not, and something you like about it or not. Cool. Today I'm joined again, as I said, by my great friend Kathleen, and she'll be sharing with us some tips and tricks on Pandas, what they are, how to use them, and basically how do we pre-process data, how do we group data, how to visualize data, and how do we get them ready for our machine learning or deep learning models. Cool. Kathleen, let me enable sharing screen, and the floor is yours.
Okay, so Pandas is a very popular library for analyzing data, for prepping it, and doing all the different things you have to do before you'd want to do a machine learning algorithm on it. It was started in 2008 by this fellow, Wes McKinney, who was working as a quant, and he wanted to get his team off doing panel data, doing all their work on Excel spreadsheets. And so he got this panel data, that's Pandas, and it's now, his company let it go open source, and it's now sponsored by NumFocus, supported by many companies. So it's really solid, but you might want to consider contributing either data or code or money to it. Wes McKinney's book, Python for Data Analysis, is free online. There's a lot more in it than you'd get in a little tutorial like we're going through tonight. And just to, the other day I was listening to this podcast, Talk Python to Me by Michael Kennedy. It's a really cool podcast. And he had on this guy, Chris Mattman, who's division manager for AI analytics and innovation at NASA's Jet Propulsion Laboratory. And he said, if you want to use TensorFlow, spend 90% of your time prepping the data and use Pandas for that. So, I mean, that's just an example of how worthwhile it is. So typically you import it using Pandas as PD. We've been using it in the session so far to read in our data. So PD, so this import statement should be familiar. You create the data. There are two main components, objects in Pandas, and there are a series and a data frame. And you can think of a data frame as a collection of where each column is a series, or you could think of the series as a column of a data frame. This tutorial starts out with as a data frame, and then breaks off into describing series. So you can create a data frame in code using a dictionary. So yes, no here. And so there's the data frame, this little data frame that it created. And you can see this is a dictionary, and that's the column headings and the data in the rows. Here's another example. You can, the data itself can be strings. So column headings Bob, Sue. The data is in these lists.
So we're creating
And you
data in
can-
columns here, right, Kathleen? We're creating data one column at a time, right? That's one way of visualizing it. So
Yes,
the column is Bob, and the content is I like it or it was awful, and another column for Sue, and so forth.
right. This is row 0, row 1, row 0, row 1 in these columns. So if you want, you can rename the index. So a data frame you see here, 0, 1, it'll have a default index in with just a numeric values, incremental 0 and so on. But you can set your index how you want it. Now they call the rows, the axis for the rows is called an index, and the axis, the column axis, is called columns. So those are the axes. And there's a lot of, so this is the index. It was set here in the columns. A series is just a sequence of data values with an index attached. So it's like a list with an index. So you see there, it creates that series out of the list 1, 2, 3, 4, 5. And you can assign an index to it. So here the index values is this list from this list, and the series, the data values are 30, 35, and 40. So there's many ways to read and write data frames. It can take in a whole lot of different values. The documentation is really good on it. We've been reading mostly CSV files, but I use Excel files a lot as input, and reading JSON is pretty nice too. So it's a lot of flexibility. If you're using imagery, that you can read Pickle and write it. So generally, you'd be reading your data from input from one of these a data file. So so here we're using this wine reviews. You have the path for the file, and you read it. And then one of the attributes for the the data file is its shape, which tells you how many rows and how many columns it has. You can actually see the columns if you want. And so the length of this has 14 columns, and they're listed this way. Writing this way is easier to see each one. You can look at a few of the first lines just to take a look and see what's going on with your data set, if it's anything like what you expected it to be. This value of head defaults to 5, but you can choose more or fewer if you want. And tail lets you see the tail end of your database. So this is the last 7 records. It also defaults to 5. Read CSV has more than 30 optional parameters, and so it's really flexible. If you want to, you can re-index it. So if you see up here, there's an unnamed column, like your data set might already have a column in it, and it gives you without a name on it. You want to set the index column to column 0, you can do that. So here now your index is 0 to 1, and you don't have that unnamed column in there. It still has 13 columns though. So before, Oh, it had 14 columns. And then when you do the, you reset that index, that becomes the index, and it has now 13 columns. So you see the shape is 13. There are some useful, very useful parameters for the read CSV. You can get the details in the documentation. You can give it a restricted list of columns. So if you have a zillion columns in your data set and you know you only want to work with a subset, you can put them in, enter them as a list, use columns equal, and it's a list. You can give them the names of the columns. So it's a unique list that's the size of the columns that exist, and then that renames them. You can set the header to be a row or rows that it defaults to the first row, but you can change that. You can read a number of rows. You can skip some rows. You can skip rows at the bottom. This is parsing dates is a nice function. It's a little bit tricky, but if you have data in your data set, this is really useful for the rest of the work you'd be doing with it. You can have it skip blank lines. So if your data set has blanks and you don't want a lot of nans, you can use that. So again, from that diagram above, you can read Excel, JSON, Pickles, SQL, lots of different ones. And then when you're writing to your data frame after you've been processing it, you don't say write CSV, it's to CSV. So it'd say PD, the data set name dot to CSV. And then the parameter would be the path for the CSV file. So are there any questions on that aspect of it?
Thank you for mentioning the additional options. There are so many out there, Kathleen. I've used mainly CSV. I've used read and write to SQL. I've used the JSON ones. I'm curious if anyone else has used other ones, or yeah, if you have any questions. So now how do you get at your data once you've read it in into a data frame? And it's a nice set of rows and columns. What can you do? How can you access particular subsets of your data? So this can be really confusing. But there's two types. There's the native Python accessors, which are pretty straightforward. It's but then there's Pandas indexing, which is it's a bit twisted from what you might be used to, but it's a lot more powerful. So so this set option here, max rows 5, will keep the when we're printing things, it limits the rows to 5 with ellipses in between, so you see the start and the end, which is kind of nice. So this is the data set. And you can see, you could use head just to see the first 5, but this way you see the top and the bottom. Scroll over, you see the column headers. This is the wine reviews data we've been working with. So you can access a column by just using the column is an attribute of the data frame. So if the column is named with a nicely, meaning it's not 2 separate words or have characters that are forbidden or whatever, you can just say reviews.country and it'll give you that column. And that's a simple way. Or you can use this, and this use the indexing operation, and you can and with the name of the string that's the data set name, and that way this could be like country of origin with spaces in between the words, and it would still work fine. And then when you do this, you're selecting a column, and then you can index into the column with a numeric value.
that's a naive way, the native Pythonic way of getting into a data set. Kind of just like as if you have an array of rows and columns and an IJ sort of thing. But a more sophisticated Pandas offers iloc and loc, and they're powerful and useful, and they can be confusing. So iloc means it's index based. So you're presuming your columns and rows are indexed numerically. You can use get the fifth row and the third column. They don't have to, the names of the columns don't have to be numeric. It'll still pick up, you can still pick up the third column, but you might not know, for instance, whereas like up here, that the third column is designation. But you could index, you could use iloc to get the rows that you want, and you can slice, you can use slicing to get particular rows. Loc is label based, so you can use then the names of the column headers or the row names. For rows, for the index, meaning the row names, if the third column is 2, then its label is 2. So loc can give you the rows in the data set in the column names. So you get the first row with iloc, and here it is. It reverses, so the native Python, we were talking before, the row would be the first index and the column the second. With iloc and loc, you choose the column and then you index into the column. So it's the reverse of what you would think. So reviews country 0, chooses the column country first and the row 0. I think I had that reversed. So iloc chooses, this chooses the column first and indexes into the column. The iloc chooses the rows. Here it's choosing all the rows, and the column, the first column, which is country. You can get the first 3 rows, the slicing, and the third column designation. You can get the first column and the second and third row with iloc. And then you can enter a list for either the rows or columns. So this gives you the row 0, 2, and 5, and the first column. Again, that's country. And you can go in reverse. So you can get the last 5 rows with a negative index. Now loc is a label-based selection. And so you would use that. So this gives you the label of the 0th row is 0, and the label of that column is country. So that gives you the first country, the country in the first row. And so you can give it a list of column names, which can be really handy because you're not thinking of your columns so much in the order that they're in. You're thinking them more of the name of the variable that they represent. One of the parts of that, though, that gets to be confusing is that with loc, it includes the last value, which is it's not typical of anything in Python with lists, with slicing lists. But that's what you wouldn't want to say, I don't know what the column is after points, so I don't want to say taster Twitter handle points, whatever that is, to get me to to pick up these particular columns. So loc actually includes the last one. And that can be kind of confusing, particularly if you're using numeric values. It will include the last one. So that's what this section is talking about here. So loc indexes inclusively. 0 and 10 will select entry 0 to 10. You can reset your index to be one of the columns if that's more relevant and important to your particular data set. So here they set the index to be the column name title. So now this is the index. And you can see when it displays it, it's different from the actual column names up there. And but the shape stays the same. So it's got 13 columns. Conditional selection, you can give it a Boolean expression. And this, if you say reviews country equal Italy, it gives you a series of Booleans where true or false if the country itself is Italy. And then you can use that and insert it as the selector in loc. So reviews loc. This gives you all the rows where country is Italy. And you can see it doesn't have a column selector because it wants all the columns. So this is selecting rows. So this one here, it's choosing all the rows where the country is Italy and these two columns. So here you're using it, inserting a list as the column selector. Note that when you're doing this above, it's not changing it's just presenting what this data frame would be. It did not change reviews. So reviews is still the same. You can combine the logical operations, but note that you want to use and in the bar for or because it doesn't like so this is country where the country is Italy or the points are over 90, over or equal to 90. So do not use the words and or, even though you can use them in other logical expressions in Python. Here's this lets you use is in. So if you want to say, instead of saying the country is Italy or is France or is Switzerland, you can say is in the set. And that selects out the countries, Italy, France. And you can say where the price is not null, where a value, and so that selects out the rows where that column is not null. So we look at price here, and you don't see any nulls. Of course, that doesn't prove it. There could be nulls in here, but that's indicating that that's not null. And let's see. So this is the shape, is a characteristic of a data frame. It's the rows and columns. The shape 0 is the number of rows, and this says there are 8996 where there's no price. You can assign data to values to cells in data frames. Pandas is kind of smart about how, what you want to do. So if you say reviews critic equals everyone, reviews critic is a row, is a column. It seems strange to set it equal to a string, but it knows that you want to set every value in that column to that string. you can set, you can create, you can set, if you have a list that's the length of the data frame, the number of rows, you can set that equal to, you can just create a new column or set a column equal to the values to that list, and it knows to insert them into. So this reverses this just creates a list with the reverse values, and it knows to set that equal to this column named, this new column named index backwards. Again, this doesn't change the data frame, so it's not in place. Guess we picked up. Oh, this does change the data frame, I'm sorry. This created a new column called index backwards. So now you see that there's 15 in there. I'm going to skip this one. This just says that I can make up a list, the length of it. If the list is not the right length, this will crash. So that would have crashed. So are there any questions on this indexing and selecting? I found loc and iloc a little bit difficult to get used to, because I started out just using the naive native Python indexing, but it's really worthwhile to get practice using that.
Yeah, I usually use loc on my day-to-day job, and something that we also mentioned on the chat is when you do the conditional indexing and when you do filtering, basically, make sure you use parentheses. So for example, when you were looking for country, Italy, endpoints more than 90, make sure you use parentheses. Otherwise, if you don't use parentheses, your code will run, but I don't think the selection will work. You might get all the countries or all the points.
Yeah, that's pretty helpful. I mean, it's not good for it to run when it's not doing what you expect it to do.
Yeah.
Kind of a general question, but yeah, I've used Pandas a fair amount, and one of the frustrations I've frequently run into with indexing, selecting, and assigning is this chained assignment warning, where you can get unpredictable results if you start trying to assign to these chained notations, right? So in some cases, it's a lot safer to use .iloc or .loc with both of them in a single bracket, rather than having one bracket that selects the column followed by one that selects the rows. Sometimes pandas can get confused in that, and I have yet to really predict when I'm going to get this error.
I second that.
Yeah, I have to agree on that.
But I was hoping that this course would provide some great enlightenment on that, and that they don't.
Yeah, it doesn't go that.
Yeah.
And it points you to the explanation for that problem, and I find that like mud. I
Right.
maybe spend an afternoon sometime playing around with it, but I don't find it very clear how to understand what's going on. I find using copy is helpful. You know, so you're copying the data frame before you subsample it or something. But yeah, that's one of those things that I'm not.
So I think since this course was introduced, they've added another access mechanism, the .at. I don't know if anyone's familiar with that, but I think
.at?
Yeah, AT. I can't
No.
recall exactly what the difference is between that and loc and iloc, but I thought it was supposed to address some of those issues.
I mean, it seems like it should be a pretty straightforward thing. You just want IJ, give me the column, give me the row, you know. But
okay, it's for single values. I'll just put it in the documentation.
So it gives you a cell?
Yeah, and you can use it to assign at a particular cell, and apparently that's safe from the chained assignment error. But it still doesn't solve the problem if you're trying to assign an entire row at a time or something.
Right.
There are also a lot of other pretty cool mechanisms too, like I think update is another option that you can sometimes like overwrite just with an index that doesn't have the whole index, but it finds which ones are in the index and updates just those. But I think that's just a, you know, in a course like this, you can't possibly come close to the total power of pandas. You can just hope to gain an appreciation for what's possible.
Yeah, the documentation's really good, and Wes McKinney's book is really good. It's got a lot of stuff. And I mean, I was thumbing through it again, looking for something here, and I thought, oh my goodness, it's, there's just a whole lot of stuff that's not in this little cursory introduction. But yeah, it's pretty powerful.
Yeah. What was the note you made about update, Robert?
Oh, I think you can. I think there's a command in Pandas update where you can. It basically works just like a dictionary update in Python.
Yes.
Okay.
I've used it in the last few weeks, and I forget now. I couldn't explain it right now, but it was very helpful.
Yeah, it essentially just modifies right in place using any values that exist in another data frame that are not null. So
okay. I'll check it out. We had a question from Eric, Kathleen. He's asking about data types. I think we're going to get to that later.
Yeah, data types are the last in the last section, second to last section of the presentation.
Give him a short answer. So characters are stored as object data type, and by default in Python in Pandas, you can override that. You can give a specific data type for a column. But we'll look at a deeper dive. We'll take a deeper dive onto data types soon.
So the values in a column don't have to be uniform type, and if they're not all the same, then they will be called object. If they're all floats, it'll say it's float. If it's a string, it's going to get called an object.
Mm-hmm.
Okay, so there are a lot of summary functions and maps you can use on your data frame. So this one is reading in the wine reviews. There it is again. Almost 130,000 rows and 13 columns. I don't know why I did this. Shape is useful. So the summary functions, describe is used, is very handy. Here it's describing a particular column and it's giving you the basic stats on it. Because this doesn't need the this option that gives you only 5 columns, but if you because it's small, but it'll give you the mean and the quantiles, and the mean, the min, and the 25th and median and 75th percentile. You can do that on an entire data frame, and any column that is a numeric it'll give you the same stats on it. If you want to do it on rows that are strings or not numeric, it gives you the most the most frequent, and the one with the most frequent and the count on that one. This is another one I like to use a lot, is info. So that tells you so these are the D types are objects, but this one, for instance, is they're all float values. So it tells you it's float. And you can see how many missing values. This is often handy when you think you're computing everything very nicely, and then you find out some variable is really messed up. It just didn't work. There are a lot of statistical summary functions. So here, for example, is the mean, but there's many more. And I like IDX max and IDX min tells you the index of the first occurrence of the maximum value or the minimum value. It's pretty handy sometimes. These two are very useful. Tells you unique values in a column. And then this is basically a histogram of those. Tells you how many, the value counts of those, how often they occur in the columns. And this goes into maps, and a mapping is a correspondence or a function from one value on a variable to a different, it revises, refines, or changes the value in it. So if you're working with a column or a series, you'll use map. If you want to work on the entire data frame and use a row as the input for the data frame, more complex, you use apply. So so the map again is for a series, including a column as a series. So this one computes the points, the mean, and then it normalizes it, removes the mean from the values in each value of this row, of this column, sorry, called points. Just as an aside, I ran this. You can put the function into the lambda function, like review points means, but it takes a lot longer because it's computing it it's recomputing the mean each time. And here it's using, this is showing you how apply works. And apply works on the entire data frame. So you create this function, and the parameter is a row, and it computes the row. Here it's doing the same thing as it did before, but it's doing it row by row. You have to tell it which axis you want it to apply the function to. And so you can see here that it normalized, it removed the mean from the points value. But the power of using apply is that you can use other information in the row. So in this one, I rewrote create another little function that would only do it if so it's working on points, but it's looking at if the price is not null, if it's not a nan, then it does the demeaning or the remeaning, I guess they call it. So you can see here that since the price was nan, not available for this row, it didn't revise the points, but for the other ones it did. And this is pretty powerful if you have stuff going on in your rows that you want to have affect another cell in the row, use apply like that. You can also do things column-wise. If you insert axis equal index, I haven't done that very much. So here it's saying that it's not done in place. So it's returning a new data frame with the revised information, but make sure if you want that to be permanent, you really want to revise your data frame that you set it equal to the output of the apply or the map. And there are other things you can do that are pretty straightforward. It can be pretty smart. Here it knows that you don't want to, this is a column and this is a column. It knows you don't want to, that you want to take the values in the column and concatenate them with the dash in between. So map and apply can be pretty powerful. You can also use keyword arguments, and up here you can have other parameters that you enter. So it's a pretty powerful application. Are there any questions on that?
Thank you, Kathleen. Yep, I use map and apply all the time, and specifically if I want to add argument as well, like you mentioned.
Mhm. Okay, so
There was some question about what's the connection between NumPy and Pandas. I think, I don't know if anybody knows more about this, but I think that under the hood, Pandas use a lot of NumPy features to make their code more efficient. But I don't know if it's built entirely on top of NumPy or just its own code. I think it borrows some nice features from NumPy.
I think it's built a lot on NumPy. In fact, McKinney's book, the first few chapters are all on NumPy.
Mm-hmm.
But yeah, that indexing can get confusing though, when you switch to how you access the data is different from NumPy arrays, from the ND arrays. So
something that I didn't see here, like you mentioned, Kathleen. So all the operations that you do, they return a new series or a new data frame. But if you want to store that result, you have two options, right? You can either do an assignment, so your original data frame equals whatever the right-hand side is, or a lot of methods have this argument called in place equals true.
yes, right.
Now you don't need a left-hand side. You just do the operation. You call a function, and you just call that argument in place equals true, and whatever changes you're doing, they will actually take effect in the original data set or data frame.
Yeah, and that's handy, but it's also confusing because many times you rename variables and you think you're all set, and it's one of those ones where you have to do it in place equals true. Depending on how tired you are when you're doing it, you can be banging your head against the wall saying, "Why isn't this working?"
Do it when you're absolutely sure. Yeah, absolutely. You're
Yeah.
your data.
Yeah.
Cool.
So now grouping and sorting is pretty straightforward, but grouping is also one of those things that's really powerful, but I think it takes a bit of practice in wrapping your head around it. So in these notebooks that I'm looking at, if I inserted the information or changed what was provided by Kaggle, I did it in this teal color. So split, apply, combine, and group-wise is you split your data up into groups, you do something to each group, and then you combine it, you split it on keys, and then after you apply some function to the groups individually, then you spit out the results, combine them by the keys, and it's a new data frame or a new object. And that comes from Hadley Wickham, who did it, coined the phrase in R. So this is saying that so far we've been using the summary function value counts, but really what it's doing is a group by function, a grouping function. So import the data. You create this. So this is grouping them by by points, and then it's counting the number of rows for each value of points. And this, when you do a group by, this here, it's a group by object, which is something particular. So this one here is getting the min price. It's grouping by points and finding the cheapest wine in the points value. So you can see that the one with lower points has a lower minimum price. If you're going up to 100 points, the cheapest you can get is $80 a bottle. So it's like a slice of a data frame, slicing up the data frame into values where they match on a particular field or particular column. So this one is saying group it by winery, apply this function where for each data frame, and each group is a data frame. The title, pick the first title. So you've got a data frame, this column is the title, and you're choosing the row 0. So here's your results are the winery, because that's what you grouped it by. And this is the first title in that winery. Okay. So again, IDX max gives the first index of the maximum value in a series. So the lambda function says, this one here says, give the row using loc of the group data frame where the maximum points first occurs, and do it for each group. So it's grouping by two values, 2 columns, country and province. And you see the first row with the maximum points. Location. This is clear what
So,
this is doing?
right, for each country province, you are basically picking up the highest rated wine.
And this picks up the first row if there are more than one row that's got the same maximum points value?
Yes. So IDX max will only pick up, it's the index of the first row where that maximum points occurs.
Are there parameters to the IDX max call?
I don't know.
Probably.
Like you can imagine that you could say 3 and it gives you the first 3 if there are 3 that occurs. I think in
Well,
the,
you could also use the equal expression to wind up with a binary index to go pull up all the rows that are equal to the max, I guess.
Yeah, you can do that.
mm-hmm. So df where df points equals df points max. Is that what you're thinking?
Yeah, I mean, I went through this notebook and I just didn't think about that until now.
Mm-hmm. So df loc where I think it'd be a little trickier to do right here, but I think you could do that, and then you should be able to get all the rows then where it's equal to the max. Yeah, that's a good idea. Here's a function called ag. It's short for aggregate, but I think the lingo is, I saw you're supposed to use ag instead of aggregate, and it'll give you the values for each of those. So in this group country, it gives you the length. So this is the number of cases for rows with Argentina, the minimum, and by price. So it gives you the minimum price and the maximum price. And the length would be should be the length of the group, because they would all have prices. Even if it were nan, I think it would be counted in the length. Do you guys think so? Think that's true?
Yeah, I haven't really used length much. I usually use count, so I don't know what's the difference in that. There's another one called size as well, and I was reading online a little bit about it, and I think the difference in just the implementation speed.
Mm-hmm. So ag, there are 13 built-in functions. I couldn't find the link where I found that the other day, last week, but you can create your own functions in here also. besides these, if there's predefined function. So that could be useful. So I think it takes a lot of practice to get really familiar with group by, and then re-practice once you haven't used it for 2 weeks or more, depending on how good your memory is, how ingrained it in your brain. So multi-indexes, I haven't used multi-indexes very much, and they don't go into it too much here. You grouping this, if you group by more than one column, you'll get a multi-index. That's not the only way to get a multi-index, but so here, these are not columns anymore, they're actually indexes, and you can do some powerful stuff with that. And it's its own data type, its own type. It's called a multi-index. And they kind of punt here, and they say the most you'll see it used is when you're resetting it back to columns. So that would be something if you're, if you want to spend some time, that would be probably a worthwhile thing to get familiar with, to play around with a lot. Is there any questions on the grouping and group by?
Just a comment from TB that this looks very similar to group by in SQL, and
Yeah,
pretty sure there's a lot of things you can do in SQL that you can also do in Pandas, and a lot of things you can do in Pandas that you can do in SQL. I'm sure there are things that you can only do in one of the other.
It's also a lot like doing group by and deploy.
So Chris, your mic is very distorted.
Yeah, sorry. It gets like that once in a while. No, this is. I'll type on the chat.
so
Yeah, I mean, Python is much more expressive than SQL. SQL.
that was McKinney's, one of his goals was to be able to do things with the grouping and that went beyond SQL. I got very familiar with grouping in SPSS and could do that in my sleep, which was a totally useless skill to have beyond the project I was working on. So sorting is pretty straightforward. You can, here they reset the index and sort values by, and you can sort it by either one variable or a list of column names. And you can do it, its default is ascending. And even though most times you want to see the largest thing first, so you'd have to say ascending is false. And then you can sort by the index to resort it by the index if you want to do that. And this is one of those things where in place equals true, I think, is important. And here they show you sorting by more than one thing at a time. So sort by country and then within country by length. Okay, are there any questions on these topics?
I don't see any in the chat. Yeah, feel free
Okay.
to post it in the chat or unmute yourself.
So here they're talking about data types for in the data frames and series. There's a data type for a column. You can use it for a specific column or the data frame itself. So for instance, price, it was float 64. Here gives you the data types for all the columns. And if they're strings, again, they're going to just come up as objects. Yeah, so this one. And you can convert a column from one type to another. So you can, points were integers, I believe. And you can, but this was something where it's not in place, so it didn't change the points. So I think you'd have to say reviews points equal reviews points as type float. And the index has is in 64 now, unless you reset the index to some list of strings or something else. Any questions on data types? So missing data. So the nans are always float 64. And yeah, so you want to use is null or PD not null. So this is selecting the rows where the reviews country is null. Where the column country is null. Okay. And you can see they're all nans. Even though the country is a string, the missing ones are nans. You can fill NA with whatever you want. And that's kind of useful if you want to switch those nans to something that you can treat as a string. So here they filled the region where the region 2 was not available. They filled it with unknown. You can also do, you can backfill and forward fill with, so it would fill with the previous, like, I guess if you sorted it, you could fill it then with the previous version, the next or most recent value. That could be a good way of an imputation sort of thing. And then replace. So here it's taking the data frame, taking this column and replacing any value of this one with that one, because the person's Twitter handle changed. This you'd need in place equals true. And that can catch you sometimes. So any questions on these topics?
Some questions in the chat. If you have a mixture of, let's say, integers or floats or characters, what would the data type of a column be?
Object.
Yeah, so if there's at least one object cell, the entire field or column will be stored as object data type.
Yeah, and if they're not all the same, I mean, you could have no strings or anything, but one, some are ints and some are floats. It's going to come back as object, I'm pretty sure.
Some are ints, some are floats. Okay, I haven't tried that. I would imagine come as float.
Yeah,
it can be a little frustrating because the nan object is always a float, and if you have a missing string, I think Pandas read CSV will throw a nan into that cell, even though you may be expecting strings in the other columns.
Yeah, if you think it would be an empty string, but
Right.
it's not. It's going to be a float 64 nan.
Now you can do a replace or something, or a fill na with the empty string, which I think I think that was in this tutorial somewhere, so I guess you'll get there.
No, we just here, fill NA.
Yeah.
So here you fill it with unknown with that string, or I mean, you could fill it with whatever you want.
Robert, this new D type O, is that the new D type that you mentioned?
No, O is just the object.
Object, okay. So
But I see that even if you fill the nans with a string, the type of the column is still object. It hasn't
Yeah,
changed.
string, the type is, even if it's all string and there are no nans or anything, the string is going to be type object.
Oh, okay.
After reading it, but apparently in Pandas version 1, now they've introduced a string D type for series as well. But for backwards compatibility, everything will default to object unless you specifically request that D type. I believe that D type probably gives you some functionality that you don't have with object series,
So in
but I haven't used it.
current version, if I want to treat something as string, I just do .str or type str.
Yeah, I mean
from an object.
you can convert it in a number of ways. Yeah.
And what are you saying about the Pandas series, Robert, here? About data types?
So I think I actually put a link way up further in the chat about it. But yeah, it's I guess I'll just copy paste it again.
So
It was at 7:38, but this is the a little description of the new string data type.
but you're saying the Pandas series can contain different types.
Yeah, an object is kind of a catch-all for anything that it hasn't classified into a more specific series.
Oh, got it.
So Robert, are you saying that when you do that D type, like, or this one here, if a column is strings, it's going to say string instead of object?
Only if you convert your Panda series to this new string type specifically.
Okay. Okay. So
I think people wanted some string functionality that you couldn't do with these object D types, since they couldn't guarantee that every element in an object series is actually a string. So what the string D type does is it does have that guarantee, and you can do certain functions element-wise that don't work in the object ones.
yeah, because getting a nan can really mess you up. You know, getting a float value when you think you're working with strings, it can be pretty nasty.
Right.
And you don't-
And I think that enough people have run into that an alternative was desired.
So the latest version of Pandas, I think, was October. It's like September or October this year. But this course is probably not, up to date with that.
So a common pre-processing step would be to identify those missing values, right?
Yes.
That's what you do, and then either remove them or fill in A or impute them, like we saw in another course in this Kaggle mini series.
Yeah. You're setting them to the mean or whatever.
But I haven't seen
Or
a step where
hot-decking them.
yeah, but I haven't seen a step where you explicitly go over each record and you check if it's a character or not, or if it's string or not. You kind of rely that if it's object, okay, it will be treated as a string, but it could be a number stored as an object.
I mean, you could count, you can get the subset of rows that are NA.
Yeah.
And then
No, I'm saying, let's say you have city names, right? You have Tokyo, Amsterdam, Paris, and then you have a number 1. How are you going to find that, right? Unless you take a deeper look at your data.
Yeah.
Because your column
That's
will be stored as object type.
Yes. That's where the 90% of your time comes in.
Hopefully not. Cool.
Okay, so renaming and combining. So this is one again, rename, you want in place equals true if you want it to be, make sure it happened. See here, so to rename, you set the columns equal to a dictionary. Here it's just renaming one column, but you could have, you could enter a larger dictionary, renaming a bunch of them if you wanted to. So here, points before is now score. But this is just printing out, this is just showing you what that would be. If you look at reviews again, and unless you say in place equal true, this, it's not really, it's not going to change it in that data frame. And you can rename an index as well as a column. So here they renamed the index equal 0. The first one they renamed first entry, the second entry, and then the rest, which you can't tell here with the ellipses, but these are all kept the original. So this would have been 0, 1, 2, and 2 to whatever, 130,000. So usually, like, you'd use this dictionary, this sort of thing, for more often for renaming your columns. But if you want to rename your index, more likely you've got a list or some other iterable that's as the same size as your number of rows, and then you set the index to that. And that's more convenient. So I mean, it's really rare that you'd want to set the first 2 values of or some values of a row to some kind of string name or something. And then the axes themselves can have names, and you can rename them. So here the row index, this whole index has got a name. It's called wines, and the columns axis is now called fields. And this shows up here when it prints it out. You can then use that if you want somehow for some reason. I think I've used that a long time ago, but I don't know that it's, Robert, or George, do you use those that much?
No, that usually I'd use them if the data set is brand new to me and I have no idea what the fields mean or the records, but usually I don't. I just rely on the column headers and just the integer-based indexing.
Yeah, yeah. So, so now how do you combine data sets, data frames? You can join them and merge. And it says that merge, anything you can do with merge, you can pretty much do with join, so they don't go into merge. I think I've used merge, but I don't remember offhand. So this is picking up 2 data sets from Canada and Britain, and the columns, their columns are equal, but if I think if the columns are not equal, that you will when you join them or concatenate them, it'll just take the union of the columns. And if the one data set doesn't have values in the other, because it didn't even have that column, it'll get nans in that. You can concatenate, the documentation on this is pretty straightforward. You can this will concatenate, the default axis must be rows, so, or index. So it concatenates it stacks them basically. So this is the Canadian, since the columns are have the same names. But notice that the indexes stay the same, so they're not unique anymore. This has 700, like almost 800,000 rows, but the last row is 38,915. So somewhere between here and there, I think there's, was it 1,200 with the British and many more of the Canadian. So you'd need to reset the index or to get that to be a nice unique index. So then you can join, and I don't like this example of joining. So this is the this is how you do it. You take one data set. Oh, it's okay. So this is just setting the index to title and trending. It's a multi-index. And the right one, it's creating two new data sets, and the right is the British with its same index. So you can see they're the same 13 values. And then, so the left join, so left is the Canadian data set, and you join it to, and here the data frame you want to join it to, and you need, since the columns have the same names, you need to suffix them. So the left ones are going to be, you want that with the suffix Canada, CAN, and the right with the suffix UK. So you can see here, this, I just did the info on this. They're all the column names. So the Canadian ones and the UK ones. And this, you can see that the Canadian, there are 40,900, and the British is only 2170 records. I was trying to find records that were a set of rows that had some values from each and some missing from each, but I couldn't do that. I don't like this example of a join, and I didn't, since this is the last one, I did not have time to come up with a better example. So this one here does that join, and then says all the columns, and just give me the rows, all the rows, I'm sorry, and give me the columns that, these two columns.
You're looking for a video that is popular in both countries, right? Is that what you're looking for?
Yeah, yeah. So yeah, so this one here does that. So this is where the Canadian UK video is not null, and the video iCanada is not null. And give me those rows. That's this one here. And it's got 2170. So that means that all the British ones were in the Canadian ones. But of course not vice versa. So
the next step would be to sort them by popularity.
yeah, and play around with them. But had that not been the last topic, I would have come up with better examples. So sorry about that. Any questions on this topic?
Yeah, this is important because usually your data set is spread out in multiple files or multiple data sources. So you need to combine them somehow. And before you do that, you need to make sure that something is common between them. Maybe fields are in common, or maybe indexes are in common. So you need to make sure that they can be properly combined. I shared a few resources online that help me from time to time on how to visualize the type of merge or join I want to do. As
Mhm.
well as a second resource that has many more notes on data science in general, including pandas. I don't see.
So for sure, you don't need to create the indexes. You don't need to say, you can join on columns that they have in common.
Exactly, and when you join, you can specify on the left data set what column you want to join on the right data set what column you want to join on.
Right.
And you
right.
could specify the suffixes like you did here. I think by default, you're going to get a _x or _y for the left and the right.
Correct. Yes.
Cool. Great. Thank you, Kathleen. This was super useful, and thank you for diving to the code with us row by row. I like that.
Okay. It was fun I kind of like the going over the iloc and loc in a systematic way, because I just kind of picked it up as I was doing it. And that other question that Robert you brought up about that chaining problem, I'd like to have a systematic way of going through that too, just so it would be easy to understand what was going on there.
If you find one, please let me know.
Even if, the solution says use lock, and I use lock, and I still get like, okay, why?
Yeah.
PB has a question here. Does it affect performance if you join on indexes as opposed to columns?
I don't know.
To generic columns. I was thinking SQL here because that looks again very similar.
So when join on index, you don't really join on index. Do you join on index? You usually append, right, on index. I don't know. Has anybody used indexes for join? I usually use columns for join.
Yeah, I always use columns.
Yeah, because that's your data structure, right? Unless your data somehow is transposed, but then I would transpose it back.
Yeah. Now, you can a separate issue. You can concatenate by rows or columns, and you concatenate more than one. You can enter a list and do a PD concat.
Kathleen, do you mind stop sharing? I want to share that resource. I think it has some nice design.
Sure.
We can
Just trying to figure out.
at the bottom stop share.
I'm not seeing that, George. I know it's there.
I think I can try on my own.
Oh, wait.
Can you see my screen?
I can see your screen.
Perfect. So these are the topics that Kathleen covered for us. So creating, reading, and writing, indexing, selecting, summary functions, grouping and sorting, data types, renaming and combining. And this is the resource that I shared with us online.
Yeah.
How do you join and how do you concatenate? And I like these visualizations that you see here. So let's say you have 3 data frames, A, B, C, D. They looks like they have the same column names or the same schema if you're coming from a database world. That means that you can just concatenate them on top of each other with PD concat. So you have DF1, DF2, DF3, you concatenated them on top of each other. Let's see some other use cases. You can use different keys here. What X is, I'm trying to remember. Oh, it looks like it's keeping track of the data frame that it came from, right? So this X, so all the entries from the first data frame has this X as the first index. And all the one from the second data frame has a Y, and all the one from the third data frame has a Z. Maybe you want to keep track of, I guess, the original data set they came from. You can concatenate across columns, so with axis 1. So now you have A, B, C, D, PDF. You're going to have A, B, C, D, PDF. And depending on if you have overlapping indices or not. So for example, you have index 0, 1, 2, 3, 2, 3, 6, 7. So there are a few indices that are common, for example, 2 and 3. So for 2 and 3, you're going to get entries across the entire line of the combined data frame. Otherwise, you're going to get missing values, not a number. Okay, some other ones. You can do an inner join, meaning you only look at entries that you have common indices for.
George, can you scroll up to that previous? So for D, column D shows up in both of them. So for rows 2 and 3, shouldn't that have a DX and a DY?
So it looks like the Ds are treated as completely different columns. So there's the D column from the first data frame and the D column from the second data frame.
Oh, so they're not unique then?
Yeah.
So I think that would come up with DX and DY.
So this is concat.
Hmm.
I think in join or merge, you're going to get the underscore.
Yeah. Okay.
Yeah. Let's see.
I think with merge, you get the underscore X underscore Y by default. And I think with join, you have to specify L suffix or R suffix.
Hmm.
Otherwise, it gives you an error.
Append is another one. I assume you need to make sure that you have the same column names. Let's see if you don't have the same column names. A, B, C, D, BDF. This one looks like it's treating D as common field. So you only get A, B, C, D, F.
One other thing that's worth noting in the way that Pandas does this here is you see that it's actually got 2 rows now with index 2 and 2 rows with index 3. And if you then try to access something from this data frame with something like a .loc2, no longer will you get a Pandas series of this one row. You'll actually get a data frame with 2 rows. So it can lead to some unpredictable behavior too.
Yep, good point.
If you're not ready for it anyway.
You can do 3. You can append 3 data frames in one. You're gonna get. Okay, nothing. I mean, here it looks like they have the same columns and different indices, so there's no issue like you mentioned before. Ignoring indices. You can ignore indices as well. So let's see. 0 to 3, 2, 3, 6, 7. Looks like it's recreating the index, right?
It renumbers it.
Ignore index true.
That
That's
doesn't
a good
seem
one
like
to use if you don't have meaning in your index and you just want to make sure you don't have collisions in the result.
But I don't find the phrase ignore index equal true to make me think that that's what it means. It clearly is what it means, but
Yeah, so you want to ignore the fact they have overlapping indices. So the index doesn't really have a lot of information for you. Okay, this is cool. Now you have mixed dimensions. So you have a data frame with 4 columns and one with 1 column, and you're concatenating them across columns. So you're putting them next to each other. Okay, the indices match, so you're good. Now, I'm hoping you get something more interesting. Let's see. Unnamed series. Okay, I'm not sure I end up with an unnamed series. Oh, you're concatenating a S2 multiple times here. Looks like you're doing that. I don't see a practical use case for this. So
if you wanted to set up like dummy cases that you're going to fill in later with something else.
Okay. Let's go to merge. I think we're going to get some more interesting examples there. So merge, yep. So when you do a merge, you have a left, a right, which are data frames or series. You have a how, which could be inner, let's see,
Outer.
right, outer, left. Default is inner.
So that on lets you do a column
On, let's do a single column, which is
if
common
it's
to
the
both.
same name.
If it's
Yeah.
not, if it's different names on the left and on the right, you have to specify the column on the left data set, the column on the right data set. Left index, right index. If true, use the index on the left data frame as its join key. I guess you can do it on index as well, not just columns. So this is for column join, this is for index join, I guess. Sort, if you want to do any kind of sorting. Suffixes by default, you have underscore x, underscore y for left and right. Copy, always copy data from the past data frame. Okay, I'll create a new copy. Indicator, add a column for each row that takes the value left only, right only. So, okay, so if you want to join it, you want to see if this value came or this row existed only on the left data frame or the right data frame. This would add an indicator for you. That's useful. Validate. Checks if merge is of specified type, one to one, one to many, many to one, many to many. This looks like well, this is from like the database world, right? If your join is of one of these four types, default is none. So I guess if you specify it and you don't have this, then I guess it will fail your merge or you'll get an error. Okay, it goes through more details here. So left, right, result, and then depending on, so here you're joining on key because key is common in both. And you're looking at the values K0 to K3, K0 to K3. And you get A, B, C, D. A, B, C, D is the resulting one. You can join on multiple keys, K1, key 1, key 2, and you're using on, so you're sure that these fields are common in both data frames, left and right. Different types of joins. So we did left. You can do a right. You can do an outer. So let's say K0, K0, K1, K2, K0, K1, K1, K2. You can do an inner, only give records that the keys match exactly. Let's see. Okay, left, right, outer on B. So the column field is B. A is the common field here, and you're seeing you're using the underscore X, underscore Y in this merge. Duplicate keys, the merge indicator, joining on index. So now the information you want to join on isn't actually an index. I don't usually typically use this kind of join. Joining key columns on an index, again, multi-index. So you have a left data frame that has one simple index, you have a right one that has a multi-index. So you're joining how inner on what? I guess you'll pick I'm not sure. How inner? On what? A, B, C, D on the index, I guess. K0, K1, K2.
Matches on the single index, it says above.
Okay. So a lot of use cases, basically. Combination of columns and index. Oh, that's interesting. I don't know why you want to do that. Multiple. Okay, you can do 3 at a time. Good to know. Merging together values within series or data frame columns. 10 series merging. Okay, this is for time series specifically. Okay, let me share the second resource. This is a very long list, but sometimes usually I do a specific type of join and I use this resource every now and then. The other one is this resource from Chris Alban. He has put this website together and has more than it has more resources, not just on Pandas, but I find this one on Pandas pretty useful. So he has one on join and merge, some very simple ones, and very basic examples, very well written, just the basics, maybe some gotchas, some bugs or something like that. He has many other ones as well on Python, deep learning, stats, and machine learning. And I think right now he's working for the Wikimedia Foundation in machine learning. So I think he's using machine learning to make Wikipedia better, I guess. Cool. With that said, I just want to wrap up by mentioning the next session coming up on Friday, feature engineering. Join us on Meetup. It's this Friday. We'll be covering a little bit about going back to machine learning and how do we deal with categorical variables and how do we do encoding, how do we create new features, how do we combine multiple columns. So we saw today we had so many columns, for example, in the wine data set, maybe we can combine the region and the variety to come up with a new feature for our predictive model in case we want to predict maybe the price or we want to predict how popular the points, or maybe we want to predict something else. And then how do we select the different features? We have so many columns. How do we pick ones that are actually most important? So yeah, this is going back to machine learning. So yeah, join us next Friday and should be fun. The recording will be posted tomorrow, friends. And thank you, Kathleen, again. This was a very interesting session.
You're welcome. It was fun.
Cool. Thank you, friends. I hope you have a great night and I'll hope to see you next Friday.
Bye, everyone.
Bye, friends.
Bye.
Ciao.